So you've probably played around with an AI like ChatGPT, right? But have you ever stopped to think about how it goes from just, answering questions to actually doing things, like booking a flight for you or analyzing a spreadsheet? Well, today, that's the exact journey we're going to take. We're going to trace that evolution from a super powerful but kind of isolated AI brain to a full-on autonomous agent that can act in the real world.
Okay, so let's get our bearings here with this quick look at the AI hierarchy. You can see how everything kind of builds on top of each other. We're going to be living at the very top of this pyramid, talking about generative AI, and specifically the large language model, or LLM. Just think of the LLM as the amazing, powerful brain that we're about to give a body to. Here's the game plan. We'll start with that core AI brain, the LLM. Then we'll see why, on its own, it's basically a brain in a jar. From there, we'll get into the fun stuff, how we give that brain hands to actually do things. And we'll compare the two big approaches. We'll peek under the hood at how an agent actually thinks. And finally, we'll wrap up by looking at what all this means for the future of building with AI. All right, first things first. What is this brain we keep talking about? Let's get right down to the foundation that this entire revolution is built on.
At its heart, an LLM is a ridiculously sophisticated prediction machine. It's been trained on just an unbelievable amount of text from the internet, learning all the patterns, the grammar, the facts, the nuance of human language. And its core job, believe it or not, is pretty simple. It just predicts the next most likely word, or to be more technical, the next token. And from that one simple trick, all of this amazing, complex, human-like language emerges. So this brain is incredibly knowledgeable. But, and this is a huge but, a basic LLM has some really serious limitations. For all its power, it's trapped. And this slide right here just lays it all out. This frames the central problem that AI engineers are trying to solve. On the left, yeah, you've got all its incredible strengths. But on the right, that's the wall of its prison. Its knowledge is frozen in time. It can't check the latest news. And most importantly, it can't take any actions. This is what we call the brain in a jar problem. It's got no senses to see the world as it is right now, and no hands to actually do anything in it. So how do we bust this brain out of its jar? How do we give it those hands and senses to interact with the world? Well, there are basically two main ways engineers go about this. First up, you've got what's called a deterministic workflow. And honestly, the best way to think about this is a factory assembly line. The steps are all laid out in advance, they're rigid, they're fixed. Step A always leads to step B, which always leads to step C. It's super predictable, super reliable, which is absolutely perfect for jobs where the process is always exactly the same. Then you have the second, much more dynamic approach, an agentic system. Now, this isn't the assembly line worker. This is the project manager. You don't give it a detailed checklist. Nope. You give it a high-level goal, and the LLM itself uses its reasoning power to figure out the best steps, pick the right tools for the job, and build its own plan to get there. And this table really gets to the heart of it. It's all about a trade-off, right? With a deterministic workflow, you, the developer, have all the control. That gives you really high reliability. With an agentic system, you give up some of that direct control, but in return, you get this incredible flexibility and power. So, workflows are for the known stuff. Agents are for tackling those messy, complex problems where you can't possibly know all the steps ahead of time. Okay, so if the agent is the project manager and not the assembly line worker, how does it actually think? How does it decide what to do from one moment to the next? Let's pop the hood and see what's really going on inside. It all comes down to this really simple but incredibly powerful loop. You'll often hear it called a REACT pattern. That stands for reason and act. It starts with a thought where the LLM says to itself, okay, here's the goal, what should my first step be? Then it takes an action, which usually means calling an external tool, like a calculator or a search engine. After that, it makes an observation. It looks at the result it got back from the tool, and that observation feeds right back into the next thought. And the whole cycle just repeats and repeats until the job is done. And check this out. This is literally what that action step looks like. The LLM isn't opening a browser and typing into Google. No way. It's a master delegator. It generates this perfectly structured piece of code, this command, basically saying, hey, system, I need you to run a web search for me with this exact query. The LLM's job is to figure out what to do, not how to do it. But, this is where things get really interesting, because it doesn't always go according to plan. things can go wrong in some really weird and unexpected ways. Let's look at a real-world debugging story that teaches a massive lesson for anyone building these systems. So an engineer builds an agent. They give it a super simple test. Hey, what's 2 plus 2? And the agent comes back with this answer, 22. What? What on earth just happened? So the engineer dives into the logs, right? They look at the trace of the agent's step-by-step thinking, and there it is. The LLM, in its action step, sent the numbers to the calculator tool as text, as strings, instead of as actual numbers. So the code just did what it was told and stuck the string 2 and the string 2 together to get 22. It's a perfect lesson. You have to treat everything an LLM gives you like it's untrusted input. And it shows why being able to see those internal steps, what we call observability, is everything. Without that trace, finding this bug would have been an absolute nightmare. In that little 22 story, it's the perfect doorway into our final topic, how the entire job of being an AI engineer is being fundamentally rewritten right before our very eyes. Look, the days of just being a model trainer are kind of over. The modern AI engineer, you're an architect of intelligence. You're responsible for the whole shebang, the data pipelines, the cloud infrastructure that it all runs on, and yeah, building and debugging these weird, complex thought loops of the agent. You're the one bridging that huge gap between a cool research paper and a system that actually works and provides value in the real world. So it all really comes down to this. We've watched this technology go from being a brain stuck in a jar to an agent that can actually act in the world. The focus is shifting. The exciting question isn't just what can AI know anymore. The real question, the one I want to leave you with, is what can we empower it to do? What's the big, complex, real-world problem you would set an autonomous agent on?